Alright, so this is page 83 in your workbook, and it's asking us to estimate non-perfect squares, basically irrational numbers. So we're going to estimate them and plot them on a number line. Well, the first number we're given is the square root of 40. The square root of 40 it's not a perfect square. It's not going to be one that we know quickly. Like if I ask you what the square root of 25 is, you automatically know it's 5. Or the square root of 16, you know that's 4. But if I said, what is the square root of 40? Well, you may be stumped at that. So we want you to estimate, we want you to at least get it down to what whole numbers does it fall in between. And we can do that quickly by using perfect squares that we already know. So the square root of 40 would fall in between the square root of 36, which is a perfect square, and the square root of 49, which is also a perfect square. The square root of 36 is 6, the square root of 49 is 7. Now, we need to know what it's closer to. We know it's going to be in between 6 and 7 on the number line, but we need to get it a little closer than that. Is it 6.1 or 6.5 or 7, 6.8 maybe? We need to know which one it's closer to. So we go back to this very first line and we look at the square root of 40. It's only 4 digits away from the square root of 36, but it's 9 digits away from the square root of 49. So this tells me that it is much closer to the whole number 6 than it is to the whole number 7. So on my number line, I'm going to put my final answer closer to 6 than it is to 7. And I can estimate that at probably around 6.3 would get me pretty close. Number 2, the square root of 18. Well, the square root of 18, it's surrounded by 2 perfect square root problems. And that would be the square root of 16 and the square root of 25, which we know that is 4 and 5. And we look to see which one it's closer to. 16 is 2 points from 18. 18 is 7 points from 25. So the square root of 18 is much closer to the whole number 4 than it is to the whole number of 5. So closer to 4. We know it's going to be in between 4 and 5, so I have to have it in this area. And it's closer to 4. Alright, number 3. The square root of 70. The square root of 70 falls in between 2 perfect squares. All of these will fall in between 2 perfect squares. And you can use your pink sheet to help you remember all your perfect squares. But we've got the square root of 64, which is 8, and the square root of 81, which is 9. Notice they have to be back-to-back consecutive numbers. It has to be 6, 7, 7, 8, 8, 9. It can never be a distance of more than 1 digit. You couldn't have 8 and 10 or 8 and 12. It has to be back-to-back consecutive numbers. So which one is it closer to? Well, 70 is 6 digits away from 64, but it's 11 digits away from 81. So this tells me that the square root of 70 is going to be closer to the whole number 8 than it is to the whole number of 9. So closer to 8, and so on my number line, it's going to be between 8 and 9, but it's going to be closer to the 8 than it is to the 9. Number 4, the square root of 35. That's going to fall in between the 2 perfect squares, the square root of 25 and the square root of 36. The square root of 25 is 5. The square root of 36 is 6. Which one is it closer to? Well, from 25 to 35, that's 10 digits. From 35 to 36, that's a single digit. So it is extremely close to the whole number of 6. While it's extremely close to 6, it's not quite 6. So I'm going to be in between the numbers 5 and 6, and I'm going to be very close to 6, but not touching it. So I would be able to estimate, according to this number line and according to the information I have, that the square root of 35 is probably about 5.9, 5.92, 5.95, but it's very close to 6.